Most Americans are well aware that half of marriages end in divorce. The good news is that the divorce rate in the U.S. is decreasing. However, so is the marriage rate. According to the Center for Disease Control, the 2018 marriage rate was 6.9 per 1,000 total population, while the divorce rate was 2.9 per 1,000 population. Both rates were decreased by 1/10 of a point from the previous year and the year before. It seems fewer couples are willing to gamble the risk these days and opt out of marriage. With the high risk of divorce, we found the subject of divorce to be a compelling machine learning exercise. My team analyzed an extensive dataset from Turkey, where interestingly enough, divorce rates had been increasing and were among the highest of the 33 member countries of the Organization for Economic Cooperation and Development. In addition, our analysis included an expanded dataset, augmented with responses from close family and friends. We used various machine learning methods and used the following technologies: Python, Plotly, Pandas, Matplotlib, sklearn, Seaborn, and NumPy. Can divorce be predicted based on specific attributes? Would you be willing to share what being in your relationship is really like? If we could predict the success or demise of your marriage, would you want to know?
Hello everyone, my name is Emily Bowling and I'm going to be introducing you to our machine learning project. We'd hope to find data sets on factors that contribute to the divorce rate. Factors like whether divorced couples had children, whether they lived apart, or had different political or religious views. However, we didn't find many data sets on those subjects that were available. But while we were searching, we came across a study done in Turkey a few years where divorce rates have actually been increasing. Here I'm showing the study on my screen. The title of the study is called Divorce Prediction Using Correlation-Based Feature Selection and Artificial Neural Networks. The study used aspects of the Gottman couples therapy model, a model that derives the cause of divorce using empirical evidence. The study developed a divorce predictor scale, or also called a DPS, based on the Gottman model, which was composed of 54 questions exploring the interactions and feelings between couples. The study surveyed both married and divorced couples who answered the 54 questions based on a scale of 0 to 1 and 1 to 4, with 0 being strongly disagree and 4 being strongly agree. Of course, that means 2 is neutral. Now I'm going to talk about linear regression, our first analysis. We thought the first thing to do with our data was a linear regression to see how predictable the data could be. When splitting our data into test and training sets, we got an R-squared value of 92%. This indicates that our data is predictable and linear regression is actually a good fit. For the original Turkish data set, we also chose to do lasso and ridge linear regressions. And here you can see the code that we used for that. We chose lasso and ridge mainly because they can reduce model complexity. Ridge can actually put the constraints on the coefficients, which can actually shrink the coefficients, as opposed to lasso. Lasso's good at reducing the overfitting and taking into account magnitudes. Both of these methods find the first point where the elliptical hits the region of the constraints. So if you can imagine an image of a 3D quadrant, the elliptical is the space in the middle where the points reside. Both the lasso and ridge analyses yielded R-squared scores above 80% and low mean squared error rates below 0.17. This indicates our model explains a good amount of the variability around our means. These stats suggest that we can produce predictions that are reasonably precise. Our lower MSE indicates that we are close to finding the best line to fit our model. It's no surprise, however, that our R-squared value decreased once running the analysis on our actual data set, as opposed to the training sets. That makes sense, right? In addition to linear regression, we decided to do a heat map. Sorry about that. Here you can see our heat map. A heat map's great to get an overall look into the distribution of each attribute of our data set. It's also quite pretty. We use Seaborn to create the heat map, looking at all 54 survey questions and average values. The heat map showed significant attributes of the data set, specifically some of the more negative survey questions. You can also see that the heat map was a great way of looking at the whole data set. It shows how much each feature affects our predictions, with the higher number or the darker colors, so anything up in this darker range, having the most effect. And with that, I'm going to kick it off to Nicole. She's going to talk about some of the classification methods that we use. Thanks.
Hey there, this is Nicole, and for this next model, we chose a random forest. It provides a strong modeling technique that is more robust than just using a single decision tree. A con to a decision tree is something called overfitting, which allows the model to learn from what you would call noise in the training data, which could ultimately have a negative impact on the model's performance. Since the random forest model aggregates a multitude of decision trees, it limits overfitting and error due to bias, which yielded more useful results. The random forest was utilized to identify the feature importance, i.e., which of the 54 questions carried the most weight in predicting outcomes, either married or divorced. These 6 questions were identified by the random forest model as being the top features in order of importance, with the top feature at 13% for attribute 40. Our analysis identified a different set of priority features when compared to the top features identified in the Yontem study, which were questions 6, 11, 18, 26, and 40. Those will be mentioned later, but what's worth mentioning right now is that attribute 40 both appeared at top feature importance for our model as well as Yontem studies model. After that, we went ahead and plotted the confusion matrix to visualize the performance of the random forest model. It was determined to have an average 89% F1 score from our train test split data. This yielded 23 true negatives, 20 true positives, and 4 false negatives.
Hi there, this is Tammy, and I'm going to walk you through some of the machine learning model analysis we did as part of this project. We wanted to take a look at 3 different machine learning models in a couple of different ways and compare how these models performed with our data in order to predict the outcome of divorce. So looking at the blue section of our chart here, we can see that the first 3 models that we run were KNN, linear SVC, and SGD classifier. And we ran these against all the features, meaning with no feature selection here, looking at all 54 of the questions. We ran these models both with our combined data, which includes the responses from our close family and friends, and also with the original data from the study. Secondly, we narrowed down the features to 6 features that were selected as part of the feature importance exercise with the random forest analysis. We looked at these models both for the combined data and the turkey data only again. And as we can see, the KNN model performed the best when we're looking at the combined data, having a 97% accuracy, or 98% nearly there. While looking at the turkey data only, the linear SVC was the best performing model. When we look down in the performance scores in the random forest section, we see that for the most part, the random forest numbers are lower performing, which may indicate that we don't have quite the right importance of, or the feature selection was actually very low scoring, and so therefore probably didn't play much, didn't have much impact in the scores of the data. We do see that the SGD classifier was the worst performing, looking at the accuracy data of the accuracy of the turkey data only. Now looking at these models and their scores, we ran a confusion matrix of the KNN, or the best performing model, as well as a confusion matrix of the SGD classifier, the worst performing model. And we can see here, KNN is looking pretty good. It looks like a pretty good model that fits this data and can help us make predictions. However, the SGD classifier isn't working so well for us. We see it came up with 16 false negatives. And so the model doesn't really quite work for this data. Maybe SGD classifier would be better off looking at larger data sets, and perhaps KNN perform better because we're looking at a smaller set of data here. That's it for the machine learning section, and we look forward to discussing this with you in more detail. Thank you.
Hi, my name's Christina, and I'm going to be talking about the supporting analysis and visuals. So here, we're going to start with the aggregation of the data. I imported the CSV using pandas, and then we kind of aggregated the answers so that I could see who answered exactly, 0 to 4, so disagree to agree. And then I was able to count them all and aggregate them how we wanted to, not using the twos because twos were neutral, and in this case, it didn't apply either towards agree or disagree. So the plot that I made, the very first one, was a scatter plot, and I used Plotly to do this. So here I'm importing the CSV. I have all the rows, and then for this one, I did not want to include the American data because it was quite different from the Turkish data. So here we go down, and you'll see this is what it ends up looking like. So the red dots here represent the divorcees, and these blue dots represent the married Turkish people. So the answers really vary among the divorcing people, and then not much diversity among the married people. This will also be up on the website. And then here we will look at the bar chart, also a Plotly bar chart. So what I did here is we pulled out the 6 most important questions that the researchers noted for us to determine, who would be likely to divorce. Now, just to provide some more context to this bar chart here, I have the questions pulled up right here, and they correspond with question 2, 6, 11, 18, 26, and 40. And again, these were called out for being the most important questions of the survey. So you can see on question 2, I know we could ignore our differences even if things get hard sometimes. You see that the married population answered with a 3% agreeable response. Now the divorced population has a 68% agree response. Number 6, we don't have time at home as partners. You'll see 1% of the married population agreed with this statement, while 6% of the divorced population agreed. Number 11, I believe that in the future I will look back and see my marriage was harmonious. There is nothing here for the marriage population because 0% of them agreed, while 90% of the divorced population did agree. The same thing is for 18, 26, and 40. The marriage population did not agree at all, so they are not represented on this chart. Number 18 says, my spouse and I have similar ideas about how marriage should be. The divorced population responded with agreeable at 77%. Number 26, I know my spouse's basic anxieties. The divorced population had a 68% agree response. Number 40, we just start to talk before I know what's going on. A sudden argument, in other words. 94% of the divorced population agreed with this statement. This concludes our presentation. Thank you very much for listening to all of us. All this information can be found up on our website at cdshary.github.io/final project. So again, thank you very much. You may also find all this information, all of our data and coding up on our GitHub account at github.com/4datawoman facebook.com/final_project. Hopefully we'll be able to answer any questions you may have. Feel free to ask away. Thank you very much again.